In the previous session, we had seen the meaning of consistent and inconsistent simultaneous equation. Let us consider an example. Without actually solving simultaneous equations given below, decide whether simultaneous equations have unique solution, no solution, or infinitely many solutions. Let us consider an example. 2x minus 3y is equal to 1 and 6x is equal to 3 plus 9y. While solving this type of equation, you should always express the given equations in general form. Let us do so. 2x minus 3y is equal to 1 is already in the general form, so we have expressed it as it is. Whereas 6x is equal to 3 plus 9y can be expressed as 6x minus 9y is equal to 3. Comparing these equations with the general equation, a1x plus b1y is equal to c1 for the first equation and a2x plus b2y is equal to c2 for the second equation. Find the values of a1, b1, c1, a2, b2 and c2. Here the values of a1, b1, c1, a2, b2 and c2 are a1 is equal to 2, b1 is equal to minus 3, c1 is equal to 1, a2 is equal to 6, b2 is equal to minus 9 and c2 is equal to 3. Therefore, getting the values of a1 upon a2 is equal to 2 upon 6 is equal to 1 upon 3. The value of b1 upon b2 is equal to minus 3 upon minus 9 is equal to 1 upon 3. And the value of c1 upon c2 is equal to 1 upon 3. If you compare these values of a1 upon a2, b1 upon b2 and c1 upon c2, you will find that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, and therefore as these values, as these ratios are equal, therefore these simultaneous equation 2x minus 3y is equal to 1 and 6x is equal to 3 plus 9y will have infinitely many solutions. Now let us go to the next part of this chapter, that is equations reducible to a pair of linear equations in two variables. In this part, you will come across the equations which are not linear, but they can be converted to linear equations by proper substitution. You will understand this when we consider an example. Let us consider the two equations. In this example, solve the following simultaneous equations. 7 upon x plus y plus 4 upon x plus x minus y is equal to 5 and 14 upon x plus y minus 5 upon x minus y is equal to minus 3. Here you will find the equations which are having one variable x plus y, or x instead of x minus y, the denominators as simply x and y. Now here we do a substitution. In this case, we will substitute 1 upon x plus y is equal to m and 1 upon x minus y is equal to n. If we substitute these values in the given equations, we get 7m plus 4n is equal to 5 for the first equation. And for the second equation, we get 14m minus 5n is equal to minus 3. Now these two equations, you can solve it by the methods which you already studied in the previous part. Here I am going to make the coefficient of m equal by multiplying the equation 7m plus 4n is equal to 5 by 2. So we get here 14m plus 8n is equal to 10 and 14m minus 5n is equal to minus 3. You will find that the coefficient of m are having same sign, and therefore we are going to subtract the second equation from the first one. If you do so, then you are going to get 13n is equal to 13, therefore n is equal to 1. If you substitute the value of n is equal to 1 in any one of these two equations, you get m is equal to 1 upon 7. But we don't want the values of m and n. We want the values of x and y, and therefore these values of m and n we are going to resubstitute in the equation, let us resubstitute the values of m and n. In the equation, 1 upon x plus y is equal to m and 1 upon x minus y is equal to n. Now 1 upon x plus y is equal to m, that is equal to 1 upon 7, simplifying which we get x plus y is equal to 7. And 1 upon x minus y is equal to n, but the value of n is equal to 1. Therefore, 1 upon x minus y is equal to 1, we get x minus y is equal to 1. If you solve these two equations, x plus y is equal to 7 and x minus y is equal to 1, you will get the values of x is equal to 4 and y is equal to 3. This is the solution for the given simultaneous equations, which are in the form where we have reduced it to the linear equation in two variables and solved. Now we are at the last part of this chapter. Last year also you have studied the applications of simultaneous equations in word problems. You know that the use of the simultaneous equations is in mathematics and science and in other fields. Many students, they find this part a bit difficult as they are unable to express the given data in the equation form. And for that, let us see what should be remembered so that you can express the given data in the equation form. Whenever there is word problem, you should first read the whole problem completely so that you will get a complete view of the problem. Never read it part by part. First read it completely and then go for the parts which are having certain meaning. Many students, they find this part a bit difficult because they are unable to frame the questions. So here are certain tips for you so that you can handle this part easily. Students, always read the whole word problem completely and then make parts of it so that you can express the given word into a mathematical form. The whole word problem completely. Then allot the variables to the unknown quantities. Frame the two equations which you will be using it for solving the word problem. And lastly, never forget to write the answer in complete sentence with proper units. Now let us see the example. Here is an example. A bus covers a certain distance with uniform speed. If the speed of the bus would have been increased by 25 km per hour, it would have taken 3 hours less to cover the same distance. And if the speed of the bus would have been decreased by 5 km per hour, it would have taken 1 hour more to cover the same distance. Find the distance covered by the bus. Once you read the whole problem, you will get an idea that this problem is related to speed, distance and time. You already know the formula. Speed is equal to distance upon time. Here the distance remains same. Now we are going to make parts of this word problem so that you will arrive at two conditions and you will get two equations which will be solved afterwards. Let us see. A bus covers a certain distance with uniform speed. Now let the speed of this bus be x km per hour and the time taken to cover this distance be y hours. Therefore, according to the formula, we get the distance covered by the bus is xy kilometer. Now by the first condition, what is the first condition here? That if the speed of the bus is increased by 25 km per hour, it would have taken 3 hours less to cover the same distance. Now from this part, you are going to arrive at the first equation. Here the speed is increased by 25 km per hour. As the speed of the bus is x km per hour, when it is increased by 25 km, the speed will become x plus 25. The time taken therefore is less, and this time taken is 3 hours less, and therefore the time taken by the bus now when the speed is increased by 25 km per hour will be y minus 3. And the product of this x plus 25 into y minus 3 is equal to distance covered, that is equal to xy. This is the first condition of the equation. And if you simplify this, we are going to get minus 3x plus 25y is equal to 75 as the simplified form of the given condition. And by the second condition, when you read the second part of this word problem, you will find if the speed of the bus is decreased by 5 km per hour, and therefore the new speed will be x minus 5. As the speed is decreased, therefore the bus will take more time to cover the same distance. Here they are given that to cover the same distance, it takes 1 hour more, and therefore the time taken is y plus 1. And therefore by the second condition, we have the equation x minus 5 into y plus 1 is equal to xy, and the simplified form of this, we get x minus 5y is equal to 5. Now if you look at these two equations, equation number 1, minus 3x plus 25 is equal to 75, and x minus 5 is equal to 5, can be solved by using the method which we have studied in the previous part. Here we have multiplied the second equation by 3, and therefore we get 3x minus 15y is equal to 15, and the first equation is written as it is. You will find that the coefficient of x can be cancelled as they are having opposite signs, and therefore we get 10y is equal to 90, and therefore y is equal to 9. You can substitute this value of y is equal to 9 in any one of the equation 1, 2 and 3, and you will get value x is equal to 50. Now here they are not asked the speed of the bus or the time taken by the bus. They are asked you the distance covered by the bus. Now you know that the distance covered by the bus is x into y, and therefore the distance covered by the bus is 50 into 9 is equal to 450 kilometers. Now many students, they forget to write this last sentence. Always remember that whenever you are solving the word problem, you should always end up with a sentence of what is asked in the given word problem. Here they have asked, find the distance covered by the bus, and therefore we are having a sentence, the distance covered by the bus is 450, and we have attached the unit to it, kilometer. Never forget to write the unit after whatever quantity which you have got there. Therefore, the distance covered by the bus is 50 into 9, that is 450 kilometers. Always attach the units after the quantity which you have found. If you don't write this unit, there is always chance of losing marks. Dear students, we are in the concluding part of this session and the chapter. This chapter you will find has the highest weightage of marks. The weightage of marks for this chapter is 18, which is nearly 24%, or you will find that nearly 1/4 of the paper consists of the examples on linear equations in two variables. We hope that this session will help you to score these marks confidently. Now, in the last part of this session, we will see the hot problems, that is high order thinking skill problems, which are given at the end of the test. We have selected here two examples. First one, solve the following simultaneous equation. Ax plus by is equal to a minus b. Bx is equal to ay plus a plus b, where a and b are constants. Now if you look at this equation, then we can express the equations in the form ax plus by is equal to a minus b, and the second equation bx minus ay is equal to a plus b in general form, because here a and b are constants. Now you can solve this simultaneous equation by making the coefficients of x or y equal. If you want to make the coefficient of x equal, you can multiply the first equation by b and the second equation by a, and then solve by our usual method. But you will find it a bit tedious. So here is a simple method of solving this simultaneous equation by using determinants. You already know that d is equal to a, b, b minus a for ax plus by is equal to a minus b, bx minus ay is equal to a plus b equation, and therefore we solve this. Minus a square minus b square is the value of the determinant d. The value of determinant dx is equal to a minus b, a plus b, and b minus a. And if you simplify this and get the value of the determinant dx, you will get value as minus a square minus b square. The value of determinant dy is equal to a minus b, b, a plus b. If you simplify it and get the value of dy, we get a square plus b square. By using the Cramer's rule, you know x is equal to dx upon d, that is equal to minus a square minus b square upon minus a square minus b square, which comes out to be 1, and the value of y is equal to dy upon d, that is equal to a square plus b square upon a square minus b square, which comes out to be minus 1. Now this is a bit simple example. You will find one more example in the textbook. M into x plus y minus n into x minus y minus m square plus mn plus n square is equal to 0, and the equation m into x plus y plus n into x minus y minus m square minus mn plus n square is equal to 0. Now this is a complicated equation where x and y are the variables. Now you will have to express this in the form where you m plus x and y variable, and you can solve it by using the determinant method in a simplified way, where in this case if you use the method of making the coefficient equal, you will find it a bit lengthy and tedious. And let us see the second example in thoughts. The example is, when the son will be as old as his father today, the sum of their ages then will be 126. When the father was as old as his son is today, the sum of their ages then was 38. Find their present ages. Now we have read the whole problem first. Now let us see the part by part. The first condition, when the son will be as old as his father today, the sum of their ages then will be 126. Let us consider that the son's present age be x years and father's present age be y years. Now when the son will be as old as father today, the son will be as old as his father after y minus x years, and therefore the son's age and father's age sum at that time is 126, and therefore we are going to add this y minus x years to the ages of father and son, and therefore the sum y plus y minus x plus x into x plus y minus x is equal to 126, and the simplified form of this equation is 3y minus x is equal to 126. The second part of the equation is, when the father was as old as his son is today. When will be the father as old as his son today? Now he will be as old as his son today y minus x years ago, and therefore the ages of father y minus x years ago and the age of son y minus x years ago, their sum is given to be 38, and therefore y minus x is the age of the father y minus x years ago, and the age of the son is x minus y minus x years ago, and the sum is equal to 38, and the simplified form of this equation is 3x minus y is equal to 38. If you consider equation 3y minus x is equal to 126 and 3x minus y is equal to 38, you are already acquainted now with how to solve this simultaneous equation. If you solve this equation 1 and 2, you will get x is equal to 30 and y is equal to 52. As I told you previously that this word problem should always end with a sentence. Here we are ending up with the sentence. The present age of son is 30 years and that of father is 52 years. Here I have attached the unit years and I have written the sentence because this part of the answer carries generally 1 mark. Dear students, if you go through these 2 sessions, I hope you will get a confidence in solving the problems in the test. Along with this, if you solve each and every example in the test book and also the solved examples which are given in the test book, I am quite sure that you will get more confident and you will be able to score marks and solve each and every example in the board examinations paper. We have tried to clear many doubts which are in this lesson. Still, if you are having any doubts of this chapter, you can email to loksatta.com or YAshasvi Bhava.